Everyone. In this video, I'll be covering another famous publication in machine learning. This one is by scientists at OpenAI and is the foundation behind the modern celebrity ChatGPT, as well as other innovative language models that we're seeing today. So, this paper demonstrates how combining unsupervised pre-training with supervised fine-tuning can improve natural language processing. And it also takes us away from building task-specific models and moves us more towards building a universal method that uses transformers. So if you aren't familiar with transformers, there's the famous paper, Attention is All You Need by the scientists at Google. So definitely go check that out if you want to understand more about how attention mechanisms are helpful in understanding long-range dependencies in the sequence. So without further ado, let's look a bit at the challenge that's presented by this paper. So the original problem that these guys tried to solve was to work on one of the biggest obstacles in NLP, which is the reliance on large labeled data sets. And since they are so difficult and expensive to create, many traditional approaches that require more task-specific architectures struggle to generalize and adapt to different tasks. So these methods typically fail to fully leverage the amount of data that's out there, mostly because they are unlabeled. And this is quite a missed opportunity for us because we could potentially use that data to build more richer linguistic representations. So this paper addresses those limitations by proposing a more task agnostic framework and using a more unsupervised pre-training approach to learn more universal language representations and then build upon that with more targeted fine-tuning training to perform better on specific tasks. So the particular data that these guys decided to use was called the book, books corpus dataset, and it was very rich in its just raw sequence alone, and full of contiguous text with long-range dependencies. So this was very effective in just gaining a natural understanding of language, and it was then fine-tuned to basically perform on particular tasks like question answering and semantic similarity, and the results were quite remarkable. The particular results that I want to look at are not in the tables below in the results section, but rather right here in the abstract. 8.9% in common sense reasoning, and then a 5.7 in question answering on the race test. So these outcomes highlight the specialized model's ability to generalize even after generalized training on that particular task that it was given. So even after facing a diverse data set, it was able to learn the minimal information required to do really well on particular task-specific uh, uh, problems. So the overall contribution of this paper is actually rooted in the approach that I used. So I've already mentioned this enough, but the use of pre-training on unlabeled text basically helped the models to develop a deep understanding of language that was very transferable to specific tasks. And this more or less eliminates the need for single or specialized structures or architectures that would inhibit, inhibit model development. And this universal model, by comparison, achieves exceptional performance across multiple benchmarks still. So this is definitely a significant contribution. And the fact that a generalized model can outperform, a generalized approach to using specialized models kind of outperform task-specific alternatives on even 9 out of 12 benchmarks really demonstrates incredible versatility and efficiency. So this really changes the precedence for how transformers are going to be used moving forward to develop understandings on long-range contexts. So in conclusion, this paper presents a significant milestone in NLP, and by addressing the challenges of data scarcity and task-specific complexity, we get a better perspective on a more universal approach that we can use to deliver results with better efficiency. So this will definitely probe the frontier of NLP and perhaps even how we use transformer architectures or even other architectures when designing more generalized models and moving forward with how we apply them to more specific tasks and challenges. So yeah, this is really an interesting paper. Definitely recommend taking a look at it. And yeah, that's all I have for now.